Hello, good afternoon. My name is Professor Lee. I'm from Post-Tech University Project Management Laboratory Research Group. And I'd like to make a presentation about our research on the delay liquidated damages, so-called DLD, mitigation model based on the schedule and on the value management systems. And Ms. Choi is my research assistant. First of all, I'd like to briefly remind you the size of the mega construction project for EPC. I'm not sure how many of you are familiar with the engineering, procurement, and construction project. I believe some of you are from civil engineering and architecture, but my major research focus is on our EPC mega project, like refinery and petrochemical project. They are pretty big in terms of the size and complexity. To give you some idea, like one average contract amount of an EPC project is about 2 billion to 3 billion US dollar, just one project. And the duration is about 3 years or 4 years. And so that's the background of our study. Although the EPC project market is declining slightly from like a few years ago, but the expectation for the forecast after like 5 or 6 years, we are expecting from $200 billion to $300 billion in terms of the EPC project market. So that gives us about 5% annual growth. A little bit different from a regular infra project like civil engineering and architecture. A lot of EPC projects in the past, probably for last 6-7 years, they are experiencing some delays and cost overruns. Although most of construction projects have that kind of a problem, but EPC project experience more delays and more schedule overruns. So that's the motivation of our research, how we can mitigate those underperformance of EPC mega project. So I'm going to skip this one. I already explained to you. And this slide shows you the research process for our modeling. So we have collected some data from Korean EPC contractor and some global construction data like RS means and some WS and work crew information for some case study project data. And this is the key part of our research. Modeling. So how are you going to mitigate this delay and minimize the contractor's delay penalty, so-called delay liquidated damages. So we have 2 sub-modules. One is when the project has just one critical path. That one is option 1. And the other one is the project has more than one critical path. And practically speaking, most of mega EPC projects, they have many critical paths instead of just one single critical path. So most of EPC projects will be on this option 2 model. And so this is our research model, and we have done some test and validation to compare the actual project data to our model, which shows a pretty good prediction. So this is the project data we have collected. Like I mentioned, some of the Korean EPC contractors, and they are executing majority of EPC project in Middle East, like refinery, petrochemical, contracted by Aramco and so and so. RS means data for the construction crews, unit cost, and WBS. So we use them. I believe most of you are familiar with the earned value management systems. This shows the earned value management system schemes. And when the project is about like 75% progress, then most of EPC project, they are experiencing some delays, like 1 month or 2 months, 3 months. So the contractor is wondering, they're going to continue that delay trend to the completion of the project, which gives them a lot of penalty, delay liquidated damages. Or alternatively, they can put extra resources to catch up the delays. And so this model gives them some optimized calculation between the paying the liquidate damages at the end of the project, or they can accelerate the delays a little bit. Remind you that DLD, delay liquidate damage per day on this average EPC mega project is $500,000 or even $1 million. So if the project is like 1 month delayed, then you can imagine the total DLD is $30 million US, which is a lot of money. So the contract is struggling to accelerate the delays or pay the delay liquidated damages at the end. So this model gives you their comparison between the paying the DLD or to put up some extra resource to catch up the delay so that they can reduce the delay a little bit. But on the other hand, they should put an additional resource cost. So they need to balance between the two options. So this is an example of our case study. And you can see here, if they continue their delay trend, then the DLD at the end might be $3.6 million. But our model gives them, they can accelerate the delay a little bit so that they can reduce the like 12 days critical path. So that one is the optimal point, okay, between the two options. And this one is similar with the multi-critical path. Okay, so this is our summary as a conclusion. And this is a theoretical modeling, I know that, but contractor can take advantage of this kind of optimum simulation comparison between the possible more delay, which they need to pay delay LD, or they can catch up the delay with additional resource cost. So we believe that the contractor can expand this model and get some more practical solutions at the end. Okay. Thank you very much.